So, to continue our discussion regarding two sample tests, we will now at the t-test for the difference between means for dependent samples. So we have here a t-test can be used to test the difference of two population means when these conditions are met. So the first one, the samples are random. Number two, the samples are dependent. And number three, the populations are normally distributed, or the number of samples must be greater than or equal to 30. So remember that there's also a case where the number of samples is less than 30. So we can also use t-test for that, assuming that the population is normally distributed. So the test statistic is, so we have the formula d bar equal to the summation of d divided by n, and the standardized test statistic is described by that formula. Okay, so for example, a shoe manufacturer claims that athletes can increase their vertical jump heights using the manufacturer's training shoes. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used the shoes for 8 months, their vertical jump heights are measured again. The vertical jump heights in inches for each athlete are shown in the table. At alpha equal to 0.10, is there enough evidence to support the manufacturer's claim? So assume that the vertical jump heights are normally distributed. Okay, so let us now answer the given problem. So let us first identify what is the claim. So it says here that the claim was, so the athletes can increase their vertical jump heights using the manufacturer's training shoes. So let us write here, so the athletes can increase their vertical jump heights using the manufacturer's training shoes. So if there is an increase in the vertical jump heights using the manufacturer's training shoes, so meaning their vertical jump height before is less than the vertical jump height after. So that means this claim should be put into HA. So let us copy and then paste it in HA. Now, what will be our HO? So if there is an increase in the vertical jump heights, our HO should be there is no increase in their vertical jump heights. So we have the athletes has no increase in their vertical jump heights using the manufacturer's training shoes. So for our level of significance, so it was given in the problem, we have 0.10. And then for the statistical test, we have t-test. For the p-value, so now we will use the software SPSS to compute the p-value for our given problem. So we will first encode the given data. Let us first have a variable name, let's say x before so we will use 0 decimals, and then for the label we may type in vertical jump heights or vertical jump height before using the shoes. And then for the next variable, let's have x underscore after. So we put 0 on the decimals, and then for the label, we type vertical jump height after using shoes. Okay, so we are done in naming our data. Now let's go to the data view to encode our data. So for x before, so we encode our data. And then for after, okay, so we're almost done. So now we are going to analyze our data. So let's go to analyze, compare means, paired sample t-test. So we click that. So we will see a dialog box. Now let us put vertical jump heights before in variable 1, and then for variable 2 we put vertical jump heights after. So we're almost done. So now we click OK. So this is the output of SPSS for paired sample t-test. So as we can see, so we will look at this value. So we notice that there's no color indicating if we will reject or fail to reject HO, but we have a rule of thumb that if the given value is less than the designated level of significance, we will reject HO. So as we can see here, the p-value is 0.052, which is less than 0.10. So by that, we may conclude that there is a significant difference in the manufacturer's training shoes. So to end up our hypothesis testing steps, we fill in these missing values. So for our p-value, that is 0.052, for the decision reject HO, and for the conclusion, so there is a sufficient evidence to support the claim.